And that's me, because sometimes I can start on time, because at 8:50 we have our first speaker, Ilkay Altintas from the University of California, San Diego, which is somewhere there. Yeah. That's the rock star welcome that she deserves.
Great. I think we are ready to go. I'm going to give a sort of an unusual talk, I think, that I'm trying to more and more sort of publicize this idea of societal computing, and I'll explain what that means. But my title says AI-ready ecosystems. I want to first demystify what I mean by that and talk about the AI readiness problem. I think we all mean different things by that, but the way I define it is, and we heard a lot over the last couple of years, why do we need to be AI ready? Because we have lots of reasons. Complexity of our problems outpaced what we need to solve in the world. But also, AI is an opportunity to change the scale of discovery and progress in the society. So there is a big opportunity here. Then we can build AI-integrated systems now. We have the opportunity to continuously improve the AIs and have those part of systems, not just as standalone models that are deployed. And we had the first day panel. We want to be prepared for its risks and impacts for everyone. So this equitable AI, or things that actually ensure everyone can be a part of it, part of the AI world and the solutions. And I can list more things that we want to do or improve with it. The reason should not be because AI is inevitable. I think a lot of the times when I'm in a room discussing AI, conversation turns into that. So this is 19.
See what it's turning out.
The field became known as
61.
artificial intelligence.
Can machines really think? Even the scientists argue that one.
I'm convinced that machines can and will think. I don't mean that machines will behave like men. I don't think for a very long time we're going to have a difficult problem distinguishing a man from a robot. And I don't think my daughter will ever marry a computer. But I think that computers will be doing the things that men do when we say they're thinking. I'm convinced that machines can and will think in our lifetime.
I confidently expect that within a matter of 10 or 15 years, something will emerge from the laboratories which is not too far from the robot of science fiction fame.
So I love Claude Shannon, and I respect, but there's a spoiler alert. We are still getting ready. Since 1961, I think our definition of readiness changed, but that's where we're at. So are we ready now, or do we need another 10 to 15 years? Yes and yes. We are ready as we are, and we are starting to deploy these systems. My answer for readiness, in that sense, being AI ready will be a long journey for our society, and we'll need to build the systems. We need to build our AI muscles, so to say, to innovate using AI. So it's actually an innovation problem. It's not a technology problem, that deployment of it, but how do we innovate with it? How do we train ourselves in that innovation to be adaptive, to be data-driven, and to be human-centered? So we actually prioritize the human when we go into the AI world. So continuous innovation, how does that happen? That's an ecosystem problem. Discoverable and usable data, connected workflows that connect AI to solutions, accessible computes. A lot of what we are discussing here is how to better use compute for AI. Open science has a huge role, open data, open science. Open doesn't mean everything goes, but under some governance structures. And then through those, responsible AI integration, collaborative solutions, and scaling those models, and outcome-driven community adoption. So we need to really agree on the outcomes if we want a good world with AI. So this is what I call societal computing. And this is actually a part of the reason that over the last year I changed my whole lab structure and research around what I call societal computing and innovation. That's what we do. And the other part of it, of course, is problem solving. What are we innovating for? We are innovating for accelerating the pace of solutions for complex, those wicked problems that will need cutting-edge science, cutting-edge technology, those AIs to be integrated in the best ways possible in a continuous way. So that's what the backdrop is, right? Cutting-edge scientific discovery and the innovation pathways to bring those. Using AI, using compute, using data, of course, that's what we do. Those are our toolboxes. Can we create an AI-ready ecosystem and commit to actually using that AI in the best way possible to solve complex problems? So I'll talk a little bit about the computing model here, societal computing model, what that means for us. There are three parts to it. There's design, there's the partnerships that we'll need to build, and the integration of everything into solutions. So how do we come up with an idea? Typically, you need people who are experts in an area to say, okay, I have this problem, and I think it's possible to solve it using things, but I don't know those things. But we need to have those operational or practical insight in the room to understand what would be a scalable, sustainable, useful solution to solve, so we can create that impact pathway or innovation pathway. And that comes across the disciplines and sectors. So we need to have models to bring our minds together in a melting pot. Sometimes it gets referred to as the convergence research. And then whatever we do, fusing our science, data, AI, computing to accelerate what we understand would be a useful thing to solve. So this comes in all kinds of places: agriculture, resilience, health, education, you name it. In the society, we have these challenges. And the goal here is, those are complex. How do we make the complex simple? Again, through design, through the convergence of minds, and through integration of modular things, workflows, data services, computing systems, and also through partnerships and co-design and co-production efforts with those partnerships. We built an approach over the 10, 15 years that now we are starting to apply to different domains and creating stovepipes of solution domains around it. The first part of that is to understand what would be useful. If we solve that problem, it would be actually impactful. So usefulness is a big part of it, and that comes with a use-inspired problem. Can we come together, discuss what's the state of the possible, what's the problem to actually create an innovation pathway around that state of the possible? Where's science at? Where's AI at? And can we actually collectively merge these things to solve one problem at a time? And based on really hands-down operational understanding of the problem. Then there's the minimum viable product, easily said than done. But the innovation pathway is actually a big R&D activity. As we learn about the domain and what would be solved, creating that usable minimum viable product is the next part of the approach that then we can actually really show, okay, this is possible, and here is how. Here is, the best of science, best of AI coming together, that we aspire as researchers to be a part of that solution. And then since we start with partnerships and multi-sector discussions, when we have that usable product, it's actually a lot easier to scale and sustain it through those partnerships. Integration into societal systems, because we start within those societal systems, creating demonstration networks, creating partnership models in public-private partnerships or some form of transfer, university-innovated, government-owned, or industry-university collaborations. Lots of models that we can and we need to invent here, and we have some good examples of that. So why are we doing this? Because we are trying to harness data and workflows into solutions. At the bottom of it, my lab is still a technical lab, and with current research areas and integrated research workflows, if we know what we are solving, we can actually connect them and as effectively as possible. And those things to be connected, we need some form of dynamic behavior or composability in the systems as much as those workflows. And then linking edge cloud, high-performance computing, and the data fabric, network fabric underneath becomes a big part of the solution. Then AI needs data. Data needs to be organized into knowledge and interlinked, because this is a very multidisciplinary, cross-disciplinary area when we talk about societal systems. So we need these fairness and context-rich solutions in the data system. So when we talk about knowledge systems, we are really talking about those knowledge graphs and interlinking data. but at the same time, findability, interoperability, reusability of data, and making sure we can actually have systems and services that enable us to work with the data. And then these days, this dynamic behavior comes in the context of digital twins, and I'm looking forward to Karen's talk. Right? That how are the digital twins going to be a part of this? When we have these dynamic systems, can we actually build systems that enable those digital twins and close the loop, so to say, so that we can actually build some parts of these complex systems? And my point of view on this is digital twins are defined by the problem they are solving, because again, this is a very problem-centered approach. And then AI becomes an enabler in that picture. Can we use the AI agents, of course, but other forms of AI and collaborative AI methods to enhance reasoning and decision-making, to improve the work of creating that solution, to improve the work of actually applying it, and to improve the lives of the users. Right? AI needs to come in different contexts, and let's actually start defining and demystifying what kind of AI integration we are solving in this whole collective. Okay, that was the societal computing model. And what are those AI ecosystems? What is the platform for it? Turned out, for the longest time, that platform actually didn't exist. And I don't mean it in a, oh, it didn't exist way. It was not there. And this is communications with also the agencies in the US. And there was that missing thing that didn't help with using the things that exist to the biggest value they could provide. So National Data Platform actually started with that motivation. When we talk about composability, this is really about, can we treat everything as capable services and treat integration of services as itself a use-inspired activity? Yesterday you heard Manish's talk that useful, usable, use, that's actually in the heart of this. We are building the platform itself from that use-inspired perspective, because what problems are we solving, right? What does NDP solve? It become a big needs assessment effort in the first place, that use-inspired problems that require that AI ecosystem, the platforms that enable that ecosystem has been our use-inspired problem. So we can apply this to technology, not just how are we doing agriculture, right? How are we deploying technology for the public use? So what problems then we identified for NDP to solve is fragmented access to data, models, and services, complexity of those formats, their interoperability, their context in the knowledge graph sense, and their usage. We heard yesterday too, if you were at Manish's talk. And then this disconnect between who are the data producers and who is sharing those data sets to users. And how are we actually connect them in ways that more is possible. And then the deployment practices. Again, we heard in Manish's talk that those deployment practices, the customized services and deploying them, is a real challenge if you don't have a group of developers in your wheelhouse. And how do we then link usage of data to scalable compute? In the research domain, research compute, but any compute, right, in these public-private partnerships that are increasingly encouraged by the governments. For a good reason, because industry efforts in deploying these systems it's a huge opportunity to collaborate and use our best strengths to solve things. And then this is really dear to my heart, because as an educator, I teach a lot of project-based courses. I can't provide research compute to my students when they're doing challenges. So how do we connect research data and compute with educational activities and create more capacity for education for everyone through their browsers? So this was a use-inspired problem we tackled really heavily. And then lack of user experiences. We can't solve problems by ourselves. These are complex problems. Partnership, collaboration is the center of the approach. Can we actually create collaborative experiences for others, building on existing national cyber infrastructure so we can solve these? So we built an architecture around this. It's a federated architecture, as expected. That federation means composability. Any capability can be brought in through services to the NDP ecosystem and deployed on those connector endpoints. So, of course, service composability and deploying those services requires also this continuum approach. Where do those services run? Do they run at the edge? Do they run in HPC settings or something in the middle? And how do we connect those? That's a huge part of the enabling of that ecosystem. But also when you have it, how do you customize it? Yes, it's good to have it in one platform that we can start using things further, but how do we actually then pick one domain, agriculture or health or education or fire, and actually build on this platform some specific experience for that community to innovate and bridge fire research in this case, for instance, to fire tech, the industry building these fire tech in ways that bring advances in fire science and data advances for fire environment data together with innovators and operational partners who are the practical experience groups. So, built on top of the NDP, we call it enabled by the National Science and powered by the National Data Platform. You'll see it on all these different interfaces to the NDP platform stack. A thing that says powered by the National Data Platform, that's what it means. It builds on those core set of services, but it customizes the experience through those centralized things to specific users. So the NDP core functionality, including authentication and access and the catalog and those endpoint service deployment, becomes part of a thing that, in this case, the FireForge platform as a part of the Wildfire Technology Commons for people to come together and do things. So this is catalog extension. This is service deployment and extension through endpoints, as you heard from Manish yesterday. And then a customized look and feel, we call those custom NDPs. So it's the full stack integration for a specific community, and Wildfire Commons is one of them. Okay, then how do we apply the innovation model? If we had these platforms, we heard about NDP and Wildfire Commons, how do we go back to that innovation model and apply it? And since I started FIRE, and this is actually has been my lab for a long time, FIRE as a domain, how do we make fire science actionable through an AI-ready ecosystem? That's actually our challenge in our Wi-Fi program. And how do we apply this was the model, understand the problems, create innovation pathways through partnership, scale, and sustain them. And then the double infinitum actually is by choice. It's not, so it's a never-ending thing, right? And these arrows here are the people. It's really a human-centered activity that defines this. So what are the components of it? So then we start with a needs assessment, grounding in operational experience and societal needs. That's the use-inspiredness of this. We actually built a whole training program around it. We bring cross-sector partners and teach this as a method of human-centered design and other types of collaboration methods too. And we run workshops that range from 3 hours to 5 days with communities. And then how do we create partnerships? And when you bring partners, how do you communicate and integrate their role in co-design and co-production processes? So we had to build a whole model around that and built actually a 40-agency partnership right now that is growing. And then the enabling digital ecosystem. That's NDP, Wildfire Commons, right? That's the AI ecosystem I was trying to communicate in the earlier part of my talk. And then how do you then create those useful, scalable, integrated systems? What is the methodology and approach of that? And I'll show some examples of that. That last bit is operational platforms, right? Then it needs to be deployable in the operational context. FireMap is one of those examples, and we've been using FireMap, building and using FireMap in operational context since 2015. So this is a digital twin of the fire environment. And how it works is we get multimodal data, use those to create fire modeling ensembles, forward models, right? And then we learn from data as we are learning about the things we don't know. We know and don't know, right, as assumptions. And then we backward propagate and assimilate them into fire models so we can actually move those models. And we use it for fire prediction. There are two contexts this is being used, and AI, cloud use, those are all in my sort of workflow-ish diagram. So when we do that, we do this for the initial attack, so next 3 hours, or extended attack for 5 to 10 days out for resource allocation. So fire management decisions, resource allocation decisions. Those are two different use-inspired problems. They require, turns out, different fire science models, simulation models. One is a quick propagation model. The other one is more of a probabilistic model of what will happen in the next couple of days. And that has to be using computing and data differently at different scales too. But more and more over the last couple of years, AI moved from inside the workflow to the outside, right? This agentic approaches, how do you actually make things more interpretable? How do you optimize the application of different models and include AI agents to it? This is a research component. And then, of course, response is always reactive. We need the best response, we need fast response, but how do you then move that to a proactive zone of mitigating? That requires knowing what's there to burn, what the risk is, in a scale that we did not need for fire response. So suddenly, Burn Pro 3D is our other operational product for prescribed fire management in this case. So we are putting risk on the ground to reduce vegetation that becomes fire risk. So to understand the scale challenge here, right? In fire response, this is the world. 30 meters 2D, you need to understand the rate of spread and direction. This is the world for prescribed fire, 3D at 1 meter scale. And the 3D models have internal fire behavior to understand what the fire is consuming from the environment. So you need to know what's there to understand what's being consumed at a detail that we didn't before. And you also need to calculate smoke effects and combine multiple scientific models for fuel, fire, smoke to actually create that solution that turns out burn bosses and planners who execute these burns do not have today. They go by guessing and experience. So again, the scale challenge becomes, this is even in 2D, 900 times more detail, then you have these 3D characteristics of the landscape. And by different measurements, for instance, like LiDAR measurements, and using different AI techniques to onboard those, we are then going to detail levels that are, m-dimensional, n-dimensional in 3D 1 meter scale. So that becomes a data problem. And then once you have those detailed models, it becomes possible to do more physics-guided approaches using AI in that case, trade-offs between smoke and risk, and also explainability techniques. This is kind of an eye candy, but it requires that data system, right? I talked about that AI-ready data ecosystem, a data system and contextualization engine. This is needed. So for instance, this is not a picture. This is a LiDAR image. This is a point cloud that's colored. How do you go from this to this? One characteristic of what kind of fuel this is. Does it become burnable in an hour, 10 hours, 100 hours, 1,000 hours? It's like a small student AI that generates that as one part of the context. Then when you know that, how do you actually create a model that shows fire behavior when you have that prescribed fire from the air and from the ground? And how do you also then communicate that? That's a staffer at our congressional demonstration in gamified settings, but you also train burn personnel, train decision makers and policy makers and what these things are. And then you can also put some more, like there's this much shrub, this many trees, you can actually quantify from data that you're learning continuously. And that's our presentation engine. And the presentation engine can change, right? Because you have that continuous AI-ready ecosystem underneath. So the scale becomes, of course, for digital twins, this is the case, right? You have so many different modalities of data. And the scale from the data sets we use just for those fuel content, vegetation content, satellite imagery at 30 meters, aerial LiDAR at half a meter, and then terrestrial LiDAR, that image you've seen at sub-centimeter scale, that point cloud that you've seen. How do we actually fuse those together and then create the landscape? It needs a collective approach for that AI-ready data ecosystem. So 4D Fuels is the case study within the Wildfire Commons. So it's, again, built on NDP, deployed on Wildfire Commons, because that's the community, and brings together people who work on what I refer to as 4D Fuels, 3D plus time, but there's all those characteristics as well. So as we are all collectively working, we are creating a catalog of every data set everyone's working on, and through workspaces, making those analyzable. So we are using the NDP workspace services to make those actually useful to the community working on those data sets, the scientists, the AI providers. And then we also bring dashboards like the field data or the burn units. These need to be understood. So burn bosses can actually interact with the system and understand how they could provide more requirements. So this is just one part of the data, but this open approach and bringing people onto a platform they can actually create services that they can deploy within their techniques becomes really useful. And if you go to the 4D Fuels, actually the site here, you can see those burn units, and you can explore and understand, which we have found is really useful for policymakers. So in the last couple of minutes, right, wildland fire is one domain. There are many societal domains and more coming. We do this for agriculture and food systems. We do this for biomedical applications, for instance, these wearables. How do we become part of solutions through those? Transportation and infrastructure, energy and climate. We have a grid data hub together with the University of Utah. And education, I said that's dear to my heart, like finding new educational methods, AI tutors, and deploying them. This is both a technology development effort, but also an education training effort that we can collectively improve. And many more, right? I think the sky is the limit. So I really see this as a societal operating system. Can we build an AI-ready ecosystem around these open platforms and science and collectively compose what we know so we can actually create innovation models together? AI will only destroy the society if we expect it to transform the society by itself. We need to find some models, and we need to couple innovation models to platforms to organize things around shared goals, those user-inspired problems. So federated hardware, federated data and services, application workflows that has an understanding of the problem and how that problem has things that need to be governed within that, and those user-facing virtual environments. This is the heart of this approach. And data and AI-aware, service-oriented platforms. I gave NDP and Wildfire Commons as an example. I think they will provide this type of enabling operating system. And the innovation approach, coming back to it, we really think there's a connective framework we can enable through that. We can imagine, design, build, scale together, and make data, science, technology to work for the public good and societal resilience. Thank you.